Section 5.3, Trigonometric Graphs. In this section, we are going to try to graph sine and cosine. So to start, we're going to look at the unit circle. And when we're graphing, it would be very difficult to graph anything with a square root, so we're not really going to pay any attention to those values. But we'll write down everything else that's important. So remember, it's cosine comma sine. So at 0, sine is 0, cosine is 1. At pi over 6, cosine is not important for our graph, but sine is 1/2. We're just going to ignore everything that's over 4 because those are always square roots. Pi over 3, cosine is 1/2. Pi over 2, with cosine is 0, sine is 1. 2 pi over 3, we'll ignore sine, but cosine is negative 1/2. 5 pi over 6, we're going to ignore the cosine, but sine is positive 1/2. At pi, cosine is negative 1, sine is 0. 7 pi over 6, we're going to ignore the cosine, but sine is negative 1/2. At 4 pi over 3, we're going to ignore sine, but cosine is negative 1/2. 3 pi over 2, cosine is 0, sine is negative 1. 5 pi over 3, we're going to ignore the sine, cosine is 1/2. 11 pi over 6, we're going to ignore cosine, but sine is negative 1/2. And then here we are back at 2 pi. Cosine is 1, sine is 0. And then anything more, if we were going up in these increments, it would just repeat. We'll talk about that more. So here we have some graph paper set up for trig because it's already split up into our increments of pi. Here's pi, and then there's 1, 2, 3, 4, 5. There's 6 equal segments, so these are all multiples of pi over 6. This would be pi over 6, 2 pi over 6, which is pi over 3, and then pi over 2, and so on and so on. So these are all of the increments that we have on our table. So let's start at 0. We're going to graph y equals sine of x. We're going to input 0 for x, and then our output will be like our y. So let's start plotting our points. 0, 0. Pi over 6, 1/2. So here's 1, so there's pi over 6, 1/2. Pi over 3 we're going to skip. Pi over 2 is 1. 2 pi over 3 we'll skip, but 5 pi over 6 is 1/2. Pi is 0. 7 pi over 6, the next one, is negative 1/2. And we'll skip 4 pi over 3 because it was a square root. 3 pi over 2 is negative 1. And we'll skip 5 pi over 3. 11 pi over 6 is negative 1/2. And 2 pi is 0. So we can see this begins shaping up to be a curve. It's a wave. That's why they call it the sine wave. I'll do my best to draw. So that's the graph of sine over x for these values at least. It would continue at these increments, so it would be back at 0 at these places, peaking there in the middle, and down here. So if you can draw in the halves as well. Now, this length that it takes for it to complete one segment of its pattern, because it is a pattern, it just keeps on repeating this part right here. That length is called its period. How long does it take to do one cycle? It starts at 0 in an increasing fashion, and it gets back to 0 in an increasing manner over here at 2 pi. So the period of the sine graph is 2 pi. You can also draw sine wave over here because negative values would be, they would repeat. So it would be at 0 at all the increments of pi. Here in the middle it would be down at -1, +1, -1, +1. And then you could also draw out our 1/2 values. And it would keep going like that, but that's enough. So now we're going to do the same thing for cosine. Y equals cosine of x. So at 0, cosine is 1. Pi over 6, we're going to ignore. Pi over 3, it's 1/2. Pi over 2 is 0. And then -1/2. We'll skip this one. Now at -1 at pi. Then -1/2. Drew that in the wrong spot. Skip. Then -1/2. Then 0. +1/2, skip, and then at 1. So you can draw that curve. And that's one period of the cosine function. It would continue. It would be at 0, and then -1, back at 0, +1. And just like sine, we can graph it on the left side of our graph as well. Be at 0, then -1, then 0, 1, 0, -1, 0, 1. And draw the curve when we have a pretty good idea of what it looks like. Also with sine and cosine, we can talk about transformations. So if you have the sine function, we already have talked about all these transformation things, but now putting it in terms of sine, a number out in front would change its, would vertically stretch or shrink to make it taller or shorter if it was a fraction. So in this case though, it changes what we call the amplitude. When it comes to sine and cosine, we call the height the amplitude. That's how high up the peaks of the waves go. You could also write that it's a vertical stretch or shrink if it's a fraction. We know when you subtract something from x in parentheses, the b is going to create a horizontal shift. It'll shift it if you subtract something, it'll shift it to the right. If you add something, it'll shift it to the left. And c, when you add something onto the back, that's going to be a shift vertically. Add something onto the back, it'll shift it up, so rather than oscillating back and forth over the x-axis, it will be over wherever it shifts to. That will be your new center line. And then k would create a horizontal stretch or shrink, so it affects the period. It'll affect the period of the graph. Since the normal period for sine and cosine is 2 pi, the period for any transformed function would be 2 pi over k. So let's look at an example where we want to graph y equals 3 sine of 2 times x minus pi over 3. X minus pi over 3 means it's going to start by graphing here, shifting to the right, pi over 3. The 3 is going to change its maximum values up to 3 and -3. Those will be the peaks of the waves. The 2 is going to shorten the period to 2 pi over 2, just pi. So since the period is just pi, that means it has to do its whole graph, which we know sine starts at 0, goes up, down, and then back. It has to do all of that in the length of 1 pi units, so that means it's going to start at pi over 3 and end at pi plus pi over 3. It will be back at 0 here in the middle, and it will peak up at 3 at the in-between points, and down at -3 at the in-between points. So the graph for just one period of our sine function will look like this.